Okay, guys, I'm going to use this session to go over the conceptual test. And then if you have any questions, we'll go over the questions. All right, so the conceptual tests 9, 10, and 11, these are the ones that we'll go over. All right, so the question number 1 refers to the pole vaulter. Evidently, they can run up to 22 miles per hour. Okay, these are the Olympic pole vaulters, though. All right, so the idea behind this is to convert the entirety of the initial mechanical energy in the form of kinetic energy to the potential energy required to clear the height that the bar is set to. Okay, but the problem is it's going to be nearly impossible to generate enough kinetic energy to clear these heights. So the running alone is not going to be able to generate enough kinetic energy for you to be able to actually clear that height, despite the fact that they can, in reality, run up to 22 miles per hour. All right, so which means that you need to be running faster than 22 miles per hour in order to clear these heights. And these athletes, as fast as they are, they cannot run any faster than 22 miles per hour, because 23 miles per hour, anything above that, is a sprinter speed. So the question is, where do these pole vaulters get the extra energy from in order to clear these heights? So the answer to that question is, obviously, they're getting the extra energy from their muscles. All right, so the kinetic energy of their motion is going to go into the potential energy of the bent pole, and then the potential energy of the bent pole is going to end up turning into their potential kinetic energy. It's going to turn into their gravitational potential energy, but they're not going to be able to generate enough of a gravitational potential energy to clear that height. So which means that they're not going to be able to generate enough height to get over the hurdle. So the extra energy will have to come from their muscles. So the extra energy comes from the chemical potential energy, the stored energy inside the muscles. All right, so question number 2, in the Galileo's incline experiment, why does the ball keep going back up the same height? Ignore surface friction. Ignore surface friction, the only force acting is gravity. Gravity is a conservative force, and what a conservative force does, it makes the mechanical energy constant. Mechanical energy is a combination of kinetic and potential energies. At the top of the incline, the entirety of the energy is in the form of potential energy, and then gravity takes over. It converts potential energy into kinetic energy. And then because there's no surface or air friction to speak of, the kinetic energy gets converted back into potential energy. All right, so question number 3, in the video shown during the lecture, when multiple kids were jumping on a trampoline, one of the kids shouted to his ankle, nearly to 30 splinters. What caused that to happen? All right, so when the kids are jumping up and down, the trampoline is energized at all times. So the gravitational potential energy of the kids will turn into kinetic energy, and kinetic energy is going to get converted into the elastic potential of energy of the trampoline, which means that the energy is going to be stored inside the trampoline. And there's tremendous amount of energy stored inside the trampoline, or in the trampoline. The energy is the capacity to do work, which means that it gives you the capacity to apply a force on something and cause a displacement. When we talk about tremendous amount of energy stored in the trampoline, we're talking about a tremendous amount of force being available that could cause displacement. Displacement could be caused in 2 ways. One way is to propel the person or people in the upward direction. The second way is to obviously cause a deformation by breaking something or smashing something. In this case, the kid's ankle got twisted. So the transformation displacement happened in the form of ankle just splintering into 30 different pieces. All right, so question number 4. This is about what happened 60 million years ago. Obviously, the dinosaurs had an ultimate bad day. So there was a devastating asteroid impact, and that abruptly ended life for most dinosaurs, as far as we know. So what was the original form of the asteroid's energy that was responsible for this extinction event? Original form, this asteroid is in space, is traveling in space, close to 20 to 30,000 miles per hour. All right, so the only force acting on the asteroid is the gravitational force, which means that the mechanical energy of the system is conserved. Asteroid's mechanical energy is conserved. So the initial form of energy that the asteroid has was a mechanical energy. So that was a combination of kinetic and potential energies. As the asteroid started to come closer to the Earth, obviously the gravitational pulse started to get stronger. And so the potential energy, as the distance started to get shorter, started to turn into kinetic energy. So the initial form of energy is the mechanical energy. Through friction, that mechanical energy turned into heat, sound, eventually caused the deformation crater. All right, question number 5. The commercial cars are designed to crumple on impact, and they race cars to break apart. So what's the idea behind making race cars so fragile? The idea behind making race cars so fragile is the final form of energy is going to be deformation. There are a couple of ways you can deform things. Number 1, you can crush them. Number 2, you can break them apart. When you crush a car, the energy is going to stay within the car. The race cars moving over 200 miles per hour, they're not going to have a large enough crumple zone to absorb the impact. Okay, the crumple zone would be the length of the car, so that doesn't make sense. So the best thing to do is to break the car apart. by breaking the car apart, with the pieces flying off the car, you're able to transfer the energy away from the car in the form of kinetic energy. So the energy is the capacity to do work, and the work is done by applying a force on something and causing a displacement. So reducing energy means that you're reducing the amount of force that's capable of doing damage. So that's test number 9.